plus 5x minus 14.
Excellent. So x times x, x squared. X times 7, 7x. Negative 2 times x, negative 2x. Negative 2 times 7, negative 14. Which indeed simplifies to x squared. 5x minus 14. Perfect.
For the second one, I have 3a squared plus 8a plus 4.
Indeed.
Mine? Yeah, plus 4. Sorry.
Perfect. Good. So 3a times a, 3a squared. 3a times 2, 6a. 2 times a, 2a plus 2 times 2, which is 4. So indeed, this reduces to what Nadi gave us, 3a squared plus 8a plus 4. Any questions on multiplying binomials? Any
I
questions?
just have a question.
Yes.
I just have a question about this. So it's pretty much like factoring a polynomial.
Yeah.
Yes. So it's the reverse. It's the reverse. Yes. So
Could you show the FOIL method? Because that's what I use, and it's actually like really makes it really easy.
you mean to change from here to here?
No, you had mentioned FOIL, and that's what I use to.
Yes, exactly.
solve.
This is exactly it. First,
Front
to,
outer analysis.
exactly. But I think Glenn was asking something else. So he was saying something because he's well advanced. He was saying this, and we discussed this. If you remember, we said that the distributive law is AB plus AC.
Mm-hmm.
But we also said that this direction we are distributing. But in this direction, we are factoring. So factoring is a major issue. So we have to understand that. We have plenty of work on factoring. And I also have some handouts that I posted. Okay, so for factoring. So from here is easy. From here is a totally different story. Not for this example, which is extremely easy, but for many other examples or problems that we're going to look at. Okay.
I did have a question
Yes.
concerning the power of 0.
Yes.
What happens when you do a power of 0 to like a polynomial?
Anything that is not 0 as the base is 1.
Yeah.
Absolutely anything. So whatever you want to power 0 is 1. As long as this quantity does not equal 0.
Thank you.
Thank you. Good?
Yeah, I like the way I think of that is if it's grouped to the power of 0, it's going to be 1. That
Exactly.
group is 1.
Yes. Now if it's like this, 3 times a squared times b to 0, then you have 3a squared because this is 1.
Right.
Perfect. Good? Good. So here we have a binomial times a trinomial. Let's practice with this for 1 minute. So x minus 3 in parentheses, and then x squared plus 7x plus 1. So here, this is not FOIL. FOIL is only for two binomials. Here, we distribute x to these three terms, and then we distribute -3 to these three terms. So don't say FOIL in this case. FOIL is only for binomial times binomial. So x times x squared, x to the third, plus x times 7x, 7x squared, x times 1, positive x, -3 times x squared, -3x squared, -3 times 7x, -21x, -3 times 1, -3. In descending order, mandatory, and clean it up. X cubed is alone. 7x squared with -3x squared, positive x squared. X with -21, -20x, and -3. If we are asked, the degree is 3, the leading term is x cubed, the leading coefficient is 1. Coefficient means numbers. Good. Same thing. Okay, so let's practice with this. Let's take a minute. For quantity x cubed plus x squared minus 6 minus 3, quantity 2x cubed minus 3x squared. So let's work on this problem, please. I did send you an email. I created test 3. If you want to register, you can. They approved it.
I'll do that now.
Do we need more time on this one? Okay, so we need to distribute first. Don't try anything. You have to use the order of operations, which means we distribute 4 first. So 4 to these three terms, 4x cubed plus 4x squared minus 24 minus 6x cubed plus 9x squared. Did we all get this step? Yes? Okay, now in descending order, I have to start with a degree, and I get -2x cubed. Then I have to continue, if it exists or not, I don't know, but I have to continue with power 2, which is 13x squared. I should continue with power 1, but I have none. So I have to get to the power 0 then, which is -24. And this is it.
I mean, if you wanted to, you could do x 0.
0 times x. Yes. Perfect.
X is 0.
Good. I think we can move on, but let's look at a word problem. Find an algebraic expression that represents the volume of this figure. This is a typical situation that you will encounter later on. So let's work on this. So we have the volume, which is length times width times height. The length is 5x minus 4. The width, which is x plus 7. And the height, which is x. This is very important to understand. Do not touch the monomial. Do not do anything to the monomial yet. First, use FOIL on these two binomials. First, use FOIL on these binomials. At the very end, you distribute the monomial. So please tell me what you get after you simplify just the multiplication of those two binomials. So distribute using FOIL and do not touch the monomial yet. To make it easier, you should always distribute the monomial last.
You say you want the answer?
Yes.
It's 5x squared plus 39x plus 28.
I think it's 35 minus 4. I think it's 31. I could be wrong. So 5x times x is 5x squared. 5x times 7 is 35x. Negative 4 times x is negative 4x.
I had a positive. Sorry.
That's okay.
Transcribed wrong.
That's okay. So 5x squared plus 31x minus 28. Only now, does it matter? Does it matter? No, it doesn't. Because a times b times c is the same with c times a times b, is the same with b times c times a. It doesn't matter. But you're putting more weight and more work into a binomial. It's much better to wait till the end to distribute the monomial. Because you already have this in descending order. And now you're just distributing this x. Can you do x squared plus 7x? Yeah, but then this will be more difficult. Slightly more difficult, not, you know. So this is 5x cubed plus 31x squared minus 28x. This is the best sequence. Get the binomials multiplied, wait, simplify, combine like terms, and then it's so much easier to distribute just a simple x. It doesn't matter if you multiply these two first, but I don't want you to think that this is the distributive law and you have to distribute x to these two, to both binomials. No, 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 no. Please be careful. First, you multiply the binomials, and at the very end, you distribute x to all three terms. Very important to understand that. Okay. You know it all. I don't have anything else to teach you here. Okay, so let's look at the topics in 5.3. I meant 5.4, of course. We're not going backwards. Okay, simplify exponential expressions using the quotient rule. Yes, we already discussed that. We didn't apply it yet. We will. Simplify exponential expressions using the quotient to a power rule. Yes, we're going to do that. Simplify exponential expressions using 0 as an exponent. Yay! And simplify exponential expressions involving negative exponents. Yes, we talked about the rule. We didn't practice it. So now we are ready to practice it. Notice that this section 5.4 has too many problems. So it's split into two sequences. The sequence of 5.4a and the sequence of 5.4b. So careful here. Good. So let's practice all these rules. Because it already had 43 questions. So that's why it's separated into two different problem sets. Good. I think this is an interesting exercise, so let's discuss it. Let's see how I am with